Hey friends, welcome to my channel. I hope all of you are safe and healthy. This is my new channel and here I will be teaching some coding language as well as few parts of data scientist course. Also, I will be sharing you my experience when I started to code and tricks that I used to overcome my difficulty. So I would request everyone to please subscribe and hit the bell icon to get more updates. Let's get started. In this tutorial, I will be showing you how to do linear optimization using Solver. Now I have divided this part into two sections, otherwise the video will become too long. So in today's section, I'll be showing you the approach, and in the next video, I'll be showing you the demonstration. Now before looking at linear optimization problem statement, I'll explain you what is linear optimization and where it is used and why it is used. Linear optimization is an important tool of prescriptive analytics. Now I hope all of you are aware of prescriptive analytics. For those who are not aware, I'll explain you in short. There are three main types of analytics: descriptive analytics, predictive analytics, and prescriptive analytics. As shown in the image, descriptive analytics deals with what has happened in the past. It deals with the past trends or historic data to predict the future. Diagnostic analysis deals to understand why did that happen in the past, what were the measures that were taken, or how frequent it has happened. Diagnostic analysis and descriptive analytics works hand in hand. Now you might be thinking why we are looking at the past data. This information actually help us to predict the future data, which is my next analytics. In predictive analytics, as I explained, all those data which we got from descriptive and diagnostic, we use this to predict the data. So it is basically like we are predicting what will happen in future. Now when I say future, it doesn't mean we have become fortune teller. We are looking at the past trends, and by applying some algorithm, we are predicting that okay, that might can happen. Now prescriptive analytics is just an advanced method of predictive. Here, when you predict what will happen, you will definitely have a lot of option, or I could say a lot of solution. Now out of this lot of solution, which one will be the best is identified using a prescriptive analytics. It gives us an optimized solution to make it happen. Linear optimization is one such optimization tool which provides us the best outcome solution through the data we have. Linear programming is one of the most important technique in operation research and prescriptive analytics. It is used when the objective function and the constraints of the problem can be expressed as a linear equation of decision variable. Now most of the people will be thinking, where will all this be getting used? Why are we learning all this? I know most of the people still complain why we have learned algebra geometry as nothing is getting used in our day-to-day life. Trust me, linear optimization is used in many industries like Amazon, Flipkart to determine their profit or to determine quantity of raw materials to make. And even if like look at the history, then we can see that linear optimization was used in the Second World War also. So if you don't know this story, I'll tell you. During the World War, the US ministry encountered by manpower and logistic related problem. And to solve this problem, linear optimization problem was used. Immediately after the Second World War, Tat Singh, who is now known as the father of linear optimization, triggered the further development of field and solution approach, and he proposed the simplex method algorithm. The problem statement which we are going to look ahead, in that we will be using the simplex method algorithm. Now let's look at the steps to perform for linear optimization. So there are total 5 steps to perform the linear optimization. The first step is to identify the decision variable. Now decision variable is your important variable by which your final outcome is decided. The second is identifying of objective function. The primary goal of decision maker is expressed through objective function. The goal can either be maximize or minimize. The third option is identification of constraint. The constraint, if I say it in a simple term, it's like a condition or a criteria that you must satisfy to get your best outcome. The fourth step is to convert into a mathematical equation. Whatever the criteria, the condition or whatever the decision variable and objective function we have identified, we have to formulate that into a mathematical equation. The fifth step is to solve the problem using solver. Now, once your mathematical equation is ready, you have to put all those equations into your solver, and solver will give you the best outcome or the best result for it. So if it is hard to remember all this step, just remember docs. D for decision variable, O for objective function, C for constraint, E for equation, and S for solver. Just remember docs and you will remember all the steps. Now let's look at the problem statement. So the problem statement we have in hand is: a cargo plane had 3 compartments for storing cargo, front, mid and rear. These compartments have the following limit on both weight and space. So for each compartment, that front section, mid section, rear section, we have been given some weight and the volume of it. Now these are the limitation, these are the criteria, these are our constraints which we have to put in our equation. Furthermore, the weight of the cargo in the respective compartment must be the same proportion of that compartment weight capacity to maintain the balance of the plane. The following cargoes are ready to be shipped in the next flight. The details are given below. Any proportion of this cargo can be accepted. The objective is to determine how many of each cargo should be accepted and how to distribute each among the compartments so that the total profit of the flight is maximized. Now here you can see that in both the table we have been given some limitations, some criteria. Also, the objective here, we have two objectives, right? So the objective here is to determine how many of each cargo is distributed in each compartment, and the second objective is to maximize the profit. Now let's solve this by using a docs method. So the first step was to identify the decision variable. Now when we look at the objective function, the objective was to determine that each cargo, how much quantity of each cargo will be distributed in 3 compartments. So this is actually becomes my decision variable. Based on this, I will get my final profit, right? So in this case, the 4 cargoes and the 3 compartment becomes our decision variable. The second objective was to identify whether to maximize or minimize the profit. Now in the question itself, they have asked us to maximize the profit. So here the objective function is to maximize the profit. The third step is to identify the constraint. Now when I start reading the question, I told you that in both the table we have been given some limitation for each cargo and as well as the compartment. That limitation actually becomes a constraint which we have to put down to get the best outcome decision. Now one more thing to notice was all these three steps which I have identified now, I easily got this from the question itself. The decision variable, the objective function, the constraint, all this I got easily. The next step is actually a mathematical equation. It's actually a big step where you have to formulate all your constraint, objective function and decision variable into a mathematical equation. Now for those who are good in maths, for them it will be just a piece of cake. But for some, I know maths is just a nightmare. And I also understand we are tired of finding x. But don't worry, I'll explain it in a simple way which will be easy to solve. So for this problem statement, we will consider cargo as x and compartment as y. So we have 4 cargoes, which means x1, x2, x3 and x4, and 3 compartment, which means y1, y2, y3 and y4. So if I look at only for first cargo, which is my C1, in that case the equation would become x1 y1 plus x1 y2 plus x1 y3. Here the x will remain constant because I am looking at only the cargo 1. Similarly, I can find the equation for cargo 2, cargo 3 and cargo 4. Now for each cargo there was some specific weight that was been mentioned in the question itself. Now we'll try to add that weight into this equation. So as you can see in the table, for cargo 1 the weight that was mentioned was 18, for cargo 2 it was 15, cargo 3 it was 23 and cargo 4 it was 12, which means the cargo one weight should not exceed more than 18, right? So in my equation, what I'll do is I'll keep the x as constant, which is my cargo one, and for each compartment, which is front, mid, and rear section, which is y1 plus y2 plus y3, should not exceed more than 18. So for cargo C1, my equation will be x1 y1 plus x1 y2 plus x1 y3 less than or equals to 18. Similarly, we will be creating the same equation for cargo 2, cargo 3 and cargo 4. Now we have added the weight constraints, but we have only added weight constraints of cargo. The weight constraints of compartment was also mentioned in the question itself. Now if you look at the table, the front section has a weight limit of 10, the mid section has a weight limit of 16, and the rear section has a weight limit of 8. Now my objective was to distribute each cargo into each compartment. So if I only look at the front section compartment, which it means that all the 4 cargo, few parts of all the 4 cargos will get into a front section compartment, and the weight of the front section compartment should not exceed more than 10. So in this case, my y will remain constant because we are looking at based on the compartment respectively. So here x1, which is my cargo 1, plus y1, which is my compartment, that is front section compartment. So x1 y1 plus x2 y1 plus x3 y1 plus x4 y1 should not exceed more than 10, which is the weight of the compartment. Similarly, we will be creating equation for the middle section and the rear section. Now we have created 2 equations, one for the cargo and one for the compartment, and we have added the weight constraints of both the cargo and compartment. Now apart from weight, there was also one more constraint that was given in the table, which was the capacity. The capacity of cargo and the constraint capacity of the cargo as well as capacity of the compartment was also been given in the question. So if I look at the cargo one, the cargo C1 had a capacity of 480, and if I look at the front section capacity, it has 6,800. So what I did is I created a table. I've added both the capacity, the cargo capacity as well as the compartment capacity. Now if I look at the objective again, my objective was to distribute these cargo into each section. Now I am looking only at the compartment section, the front section compartment section. So in that case, I will consider the cargo capacity as well as the front section compartment, and the weight or the volume capacity should not exceed more than 6,800. So in that case, my equation will become 480 x1 y1 plus 650, which is my cargo 2 capacity, plus 580, which is my cargo 3 capacity, plus 390, which is my cargo 4 capacity, should not exceed more than 6,800, which means it should be less than or equals to 6,800. Similarly, we will be creating for mid section and rear section. Now here we have finally completed our first objective, which was to distribute this cargo into each compartment. The second objective was to identify the profit, was to maximize the profit. Now to calculate the profit, if you have remembered, in the second table for each cargo there was some profit associated to it. So if I look at the cargo C1, for cargo 1, the profit that was been given in the table was 310. Now I have to identify this profit which is going to distribute it into each compartment, which is front, mid and rear section. So in this case, my profit and cargo plus the compartment will come into a picture. So in that case, my equation will become 350 x1, which is my cargo, and y1, which is my compartment, that is front section compartment, plus x1, which is cargo 1, y2, which is mid section compartment, plus x1, which is cargo 1, and y3, which is my rear section compartment. Similarly, we will be creating this equation for all the four cargoes. So as you can see, for cargo 1 it was 310, for cargo 2 it was 380, for cargo 3 it was 350, for cargo 4 it was 285. Finally, we have completed with this equation. The only step which we have to do right now is to solve this by using a solver. Now, I don't know about you guys, but I definitely feel proud after creating one equation. So even if you also feels the same, tell me in the comment box. The last step was to do is to solver. Now, as I've explained, if the mathematical equation is ready in your hand, you have to provide all that into a solver, and solver will give you the best outcome. Now, I will explain that in my next video how to do it based on solver, but I will suggest to all of you to try this on your own. If you can do it, then it will be very good. Let me know the profit which you have received in the comment box. If you're not able to do it, don't worry, I'll be explaining you in a step-by-step way how to do it in a solver. Now before that, I would ask everyone to check if you can see solver in your Microsoft Excel under data tab. If you're not able to see it, then follow these steps. Open the Microsoft Excel, go to File and then Option, and under Option you will see a dialog box that will open up something like this. So in that, click on Solver Add-in and click on Go. Once you click on Go, you will have one more dialog box that will open up, and in that you have to click on Solver Add-in and click on OK. And then, ta-da! The solver, you can see solver that has been added in the data tab. I hope all of you have liked my video. Please don't forget to subscribe, like, share and comment. I'll see you in the next video. Till then, bye.